Okay, in this lesson we're going to continue looking at something called the normal distribution. What we looked at in the last lesson was that this here is the normal distribution. Normal distribution tends to describe things about living data, so height, weight, IQ, length, all those types of things, because most people fall close to the mean, and then less and less people fall further above the mean and less people below the mean. And we talked about how standard deviation applies to that as well. So a couple questions that we looked at here. We just applied the percents. We looked at the problem where IQ was applied to this normal distribution curve. So we noticed that the standard deviation was 100. We placed that right in the middle. Or sorry, the mean was 100. Placed that in the middle. And the standard deviation of 15. So we went up and down by 15s every standard deviation. Given that, we could apply it to populations and answer a whole bunch of questions. You might want to look at that lesson if you want to get answers to these questions. We're going to do two more examples, and we can apply some of our thinking to populations and make predictions, which makes this more interesting. So this next question says, Jim raises Siberian Husky dogs at his kennel. He knows from data he's collected over the years that the weights of adult male dogs are normally distributed with a mean of 52.5 pounds. So the average dog right in the middle here is 52.5 pounds, and the standard deviation is 2.4. So every standard deviation we go up or down will increase or decrease by 2.4. So I'm adding 2.4. If I add another 2.4, I'll have 57.3, and another 2.4, I'll have 59.7. And if I go down by 2.4 is 50.1, 47.7, and finally 45.3. So that's how I've labeled the normal distribution curve based on these dogs. Part B says, what percent of adult male dogs have a weight between 47.7 and 52.5 pounds? Well, those would be these dogs here. And the percents from the previous question, those never change. So these percents inside here never change. So this is 34% and this is 13.5%. So if we add those two, we'll have a total of 47.5%. In our next example, it says, what percent of adult male dogs have a weight below 50.1 pounds? So below 50.1 pounds would be this group of dogs here. And if you look at the normal distribution, or I can add the numbers in for you, this piece is 2.35%, and this is 0.15%. So if you add those, you will get 16% of dogs. I'll just fill in the rest of the normal distribution. Because it's symmetrical, these percents never change. The final question we can make a prediction about says this: in a population of 270 adult male dogs, approximately how many would have a weight below 50.1 pounds? Well, we already know that 16% of them, this is from the previous question, 16% of them would. So the question would be here, we can make a prediction about 270 adult male dogs. We want to know what 16% of 270 is. So in this case, in order to do that, we multiply 0.16 by 270 dogs, and 16% of 270 is roughly 43.2, and since dogs are whole dogs, we could round that to 43 dogs. That's our prediction. All right, so our last question here has to do with more of an interpretation of standard deviation. This question here says, investigate the normal curves for the masses of luggage for men and women on international flights. Who has the greater average luggage mass, women or men? So if we look here, if you look at these two distributions, it appears like women have a taller distribution, but that actually doesn't mean that much. What we're investigating here is the standard deviation and the mean. So for both cases, what you'll see here for men, maybe I should do that in blue, men, the mean is 6.35, and for women, the mean is also 6.35. So they're actually identical. So who has a greater average? Neither. They are the same. And our last question says this: who has a more consistent luggage mass, women or men? And we talked about this in a previous lesson having to do with standard deviation. Consistent equals a smaller standard deviation. or in other words, things is more clustered together. If you look at women here, their standard deviation, which is this distance here, is much smaller than the standard deviation for men. So since women have a smaller standard deviation, and this is why you're saying the women's normal distribution being more together, since they have a smaller standard deviation, they are more consistent. So the answer here would be women, and the reason, because they have a smaller standard deviation.